December 19th, 2023, going to do an overview of the interior of the commercial building on 4189 Swiss Lane, 4156 Swiss Lane. Okay, 16-foot sidewalls. The building dimensions are nominally 36 by 75. The building was completely remodeled 8 years ago, 2016. I'll confirm that date. It's got a garage door on each end. Garage doors are 12 foot wide, 14 foot tall. Both of them have commercial openers. The building is during the remodel construction was completely gutted interior and exterior. On the interior, it was super insulated as the new sheeting was installed. First, the roof sheeting was put on. The newest fiberglass blown-in insulation was blown in as the sheeting was put on, filling up a 12-inch cavity. As the wall sheeting was put on, same thing was done, is roughly 3 times what the normal commercial building insulation value would be. Then the electrical was done. We currently have a 200 amp single phase 240 volt, technically it's a split phase, but 240 volt panel. Right next to that panel we can come through from the meter with another panel if we wanted to do an off-peak panel, which makes it very convenient for that. Throughout the building the electrical was done in a high-end commercial manner, which means you've got junction boxes and you've got drops. So expanding the electrical at any time in the future is much more economical. We have multiple circuits for all of the outlets, and we've got high power run on both sides of the building. Here we've got 240 volt 50 amp plug, got a 20 amp plug, and next to the left side of that is the 240 volt 20 amp plug. On this side of the building, we've got a main distribution panel for high power outlets. 50 amp, 4 wire, 240 volt, 120 volt, and 220 volt. We have a built-in exhaust fan. There are 3 ceiling fans in the building. The heating system consists of 2 natural gas furnaces, 100,000 BTU each. That is it is twice the capacity that would technically be required, but provides 3 distinct advantages for this type of space. Number 1 is duplication. One furnace fails in a commercial setting, you can be down. In this case, one furnace fails, the other one keeps up, and you have as much time as you need to get the repair made. Number 2, duplication for evenly heating. And they're both operational. The building is more evenly heated, commercial space such as this, big open commercial space. And 3, if you need to superheat the building, if you're bringing in equipment to thaw out, frozen equipment that's full of snow and ice, etc., can be done much quicker. Bathroom, full bathroom, corner of the building, 7 foot by 10 foot, approximate dimensions, with the space above the bathroom customarily, as you would see. Bathroom is half bath, well, 3/4 bath, I guess, actually. You've got the laundry sink, you've got the stool, and you've got a shower. So that's correcting me. It's a 3/4 bath. On-demand hot water, water meter. If a person is using this as a rental, you can separately monitor water. Electrical's got a sub panel. Pneumatic system. Pneumatic system is designed to have low points drained. So you see on one side of the building, you've got a low point and you go up at the appropriate slope, you go up to a peak, boom. And you go the other direction and you go down to a low point. Those 2 low point drains. Now this entire pneumatic system circles the building. So when you feed it from an air compressor, the air compressor feeds both sides of the pneumatic systems. There's pneumatic drops, 3, 4, there's 8. There's 2 hose reels, one on each corner of the building. Lighting, T8 lighting, cold weather starting ballasts, high output lighting. Floor, 6-inch concrete floor with a trough system. The floor drain has been capped on the outside of the building based on code. It could be resurrected again if you wanted to put a holding tank system in there. But this trough provides drainage for water to run off melting vehicles, etc. The construction of the building is all steel construction of frame and steel girts, trusses. So you've got vertical I-beams, 1, 2, 3, 4. 4 vertical I-beams that support the engineered beam rafter. In between the rafters are the steel Z girts, typical construction of an all-steel building.